Okay, this is our bell work. Any questions on lesson 4-3 you'd like to ask? Okay, you guys, this is number 6 on 4-3. The question is you're supposed to find the x-intercepts, right? And to find an x-intercept, what do you substitute in? You substitute 0 for what? For the y, okay? So I'm going to write y, or 0 equals 1/2 x minus 1 squared minus 2. Now, this is not in the format you guys usually see. What format is this in? It's in, not, well, it's a quadratic equation. It's in vertex form. Good. This is in vertex form. What's the vertex? 1, negative 2. Now, the nice thing, did you guys know it's easy to solve quadratic equations that are in vertex form? Because to do this, all I'm going to have to do, because this part is squared right here, there's only one x term. Do you see that? And so you can just solve for that x. When it's in the form of x squared plus bx plus c, you got two different terms, one with an x squared and one with an x. And so in order to solve it, you would have to put it in this form first, or do it by factoring or the quadratic formula. Okay? But in this form, it's really easy. So I just got to get x by itself. So what would I do to get x by itself here? Plus 2 to both sides. So I get 2 equals 1/2 times x minus 1 squared. What's the next thing I do? Times by 2. If I times this side by 2, the 1/2s cancel out. And 2 times 2 is 4. So 4 equals x minus 1 squared. Yeah, and see right here, if I square root both sides, I get, I'm going to put this side on the left side. So I get x minus 1 equals plus or minus the square root of 4. What is the square root of 4? It's always plus or minus whenever you take the square root of both sides, because think about something like this. X squared equals 9. Isn't there two numbers you can put in for x and square it and get 9? 3 and negative 3. So it's always going to be plus and minus whenever you square root both sides. So now I add 1 to both sides, and I get x equals 1 plus or minus 2. So my two answers are what? 3. And what else? Negative 1, right? Okay, so when it's in vertex form, it's actually easier to solve. It's pretty simple to solve them that way. I put a little note by that and say, if it's in vertex form, you just solve for x, something like that. Okay, are there any other questions you'd like to ask? To give the indicated form, well, it asks us to graph it. So I'm going to pull up a graph right here. Okay, yeah, that would be cool. I think it's called an iPad. No, like that paper. Okay. All right. So, you guys, I have to graph this. And so, notice, what kind of graphs are these? Are these linear, quadratic? What are they? They are linear, aren't they? Okay. So, I'm going to take right here, and this linear equation, it's written in point-slope form. So my slope is, my point is 6 actually positive 4. Because if it was on the other side, it would be y minus 4, right? And that's the form. So it's actually 6, 4. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. That's my point. My y-intercept, well, my slope, yeah, is down to the right 3, right? Down to right 1, 2, 3. Or we can go up to the left 1, 2, 3. But the domain is restricted. It only wants me to graph where x is less than 6, right? For that one. So up to over 1, 2, 3. Now, if I go 1, 2, 3, 4, 5, 6, 6 is right here, right? So I only want to graph less than that point. So I need to put a hollow circle right here, and it's going to be less than, which is to the left. Okay, so why does it have to be what? What? Yeah, it has to be less than the x is less than 6. So it can only be at 6, and it's not equal to it. So we put a hollow circle, meaning it doesn't represent 6. It's just all the ones less than 6. And then where it says x is greater than or equal to 6, that one's only going to exist to the, if I put a dotted line there, it's only going to exist to the right of that dotted line, right? So I'm going to, first of all, once again, my point, because this is point slope form, is 6, 4. So I'm going to go to 6, 1, 2, 3, 4. So it actually exists right there, doesn't it? And my slope is up 2 over 3. So up 2 over 1, 2, 3. Up 2 over 1, 2, 3. So this one goes that way, and it's only less than that. So it makes what kind of shape? A V shape. And that's called an absolute value function, right? So I could write this in absolute value form just by putting absolute values around it, right? I could write this as g of x equals the absolute value of 2/3 times x minus 6 plus 4. Right? Yep. I could write it like that. So it's the same thing. Any questions there? Okay. Is that enough questions? Oh, hey, I did not get to talk about the last page but you guys, it'll take you like 1 minute to do all the problems on the back. Everybody turn to the back side. Turn to the back side of 4-3, everybody. Can I look at those? Hey, what does it mean when it says find negative s for s equals 4? What does that mean, negative s? It wants to know the opposite. So if s is 4, negative s would be negative 4. So negative 4 is your answer. My s's and 5's look the same, sorry. Okay, so now if it starts doing negatives of negatives and stuff like that, you gotta follow the pattern. Like I want to look at maybe number 19. The absolute value of a negative q, right? And what is it? Let me see what the rest of that says. It says and q equals 8. Well, if you just start on the inside, if I replace q with 8, that's a negative 8, right? And it has parentheses around it. I times it by a negative, it becomes a positive 8, right? Yeah. And then you got to take the absolute value of it, which is going to make it a positive no matter what. So no matter what, it's going to be a positive 8. Do you kind of get that? You got to follow the logic. Now, what if there's negative? I want everybody, since I didn't get a chance to do this the other day, I want everybody to do, I want you to do all of them, 11 through 20 in your groups, and I want you to compare answers to everybody in your group. I'm going to give you 2 minutes to do that. Go. I'm going to help you out a little with this one. I want you to struggle with it a little bit so you can kind of get it. But if you guys notice, this is just the x squared minus 4 is the parabola of x squared that's been shifted down 4 units. So 2, 3, 4. Right here. And I go over 1, up 1, left 1, up 1. Over 2, up 1, 2, 3, 4. Left 2, up 1, 2, 3, 4. Over 3 from the vertex and up 1, 2, 3, 4, 5, 6, 7, 8, 9. And then also over here, reflection of it on this side, right? And you guys got this function right here. Okay? Now, the second problem asks you to go graph g of x, which is equal to the absolute value of x on the same set of axes. So now, g of x, you guys, is the absolute value of x squared minus 4. And I told you to make a table of values for this one. Okay? And when we get it this way, and instead of putting y, I'm going to put g of x. In fact, I'm going to put f of x and g of x side by side so you guys can see all the values. And we're going to start at -3, -2, 1, -1, 0, 1, 2, 3. And we're going to put those in here. And if you do that, you'll see on the first one, when we went -3, it's going to be -3, 5 and +3, 5, right? And so -3, 5, or -3, 5 and +3, 5. It's at 2, 0 and -2, 0. -1, -3, and +1, -3, and 0, -4. Now, if we compare these values over here on g of x, if I take the absolute value of those, if I put 5 in here, if I put -3 in there, -3 squared is not a +9. Some of you guys are still putting this in your calculator and you're getting negative numbers. -3 squared is a +9. 9 minus 4 is 5. The absolute value is 5. So it's the same there. If I put +3 in there, 3 squared is 9. 9 minus 4 is 5. The absolute value of 5 is 5. So this one down here is 5 as well. If I put -2 in, -2 squared is 4. 4 minus 4 is 0. So I get 0 here and 0 there. So far, everything's the same, right? But what happens when you get to -1? -1 squared is 1. 1 minus 4 is -3. But I take the absolute value of it, and I get +3. So notice both these -3's in the first one were positive right here. -4 squared is, or 0 squared is 0. Minus 4 is -4. The absolute value of -4 is +4. And so when I graph this one, I still had this point, and this point, and this point, and this point the same. But these right here reflected up to right there, and right there. And so my graph goes like this for that one. Do you see that? And so what's the only thing that changed? What changed here? Yeah, since we took the absolute value of all the y values, they flipped up and they became positive. Do you see that? Some of you guys discovered that already. You told me when I came around. Okay? So some of you guys discovered that already, and they became positive because we took the absolute value of them. So it's this function right here where you took the absolute value of the x squared and flipped them over. Okay? Thank you.
Do they call that the
Thank you.
equation?
And they don't call it the W equation. They call it the absolute value of x squared minus 4. But yeah, you could call it that if you want. Grant. Okay. So now it asks you guys, it says write this. It says explain what happens graphically. What are you going to write? What happened from the green one to the red one? The negative ones did what? Reflected over what? The x-axis. That's what I would write. Now, you guys got to really pay attention. All eyes right here while we do the piecewise function, because this is the hard part. Okay? Let me erase this. Okay, the piecewise function, we're going to call it x because that's what the second function is called, g of x. But instead of writing it as an absolute value, we are going to write it as a piecewise function. I'm going to move this back this way. Okay, so I have to do two parts. I am going to do the parabola. See this one right here? Remember the original parabola, the green one? I'm going to do the green parabola, which is x squared minus 4. You guys can't be talking right now. You've got to be listening. Okay? I'm doing the green parabola, which is x squared minus 4, except for what parts of it do I want? Because I don't want the green one. I want the red one. But where are they the same?
All the way until they're about to cross the...
So, for what number? What's this number? -2. From -2, which way? Left. How would we write that? X is less than or equal to -2. And where else? Yeah, greater than or equal to +2, because I only want this part and this part of the graph, you guys. X is greater than or equal to +2. So I've got that piece. Now, what piece do I not have? I don't have this piece, right? How do you write that piece? How do you get this piece right here? How does that happen? Well, you wouldn't even have to put absolute value signs on it because we're not going to do an absolute value. We're going to do it as a quadratic. What would change? How do you flip it over? You do the negative, right. You do negative of x squared minus 4. But what part do we want of that? Because if I took the whole thing, it's just going to continue down like this. So what part of it do I want? Negative 2 to positive 2. And so we would write it like this, colon, x is greater than negative 2, but less than positive 2, right? Because it means all numbers between negative 2 and positive 2. That would be the piecewise function that would generate the same thing as g of x equals the absolute value of x squared minus 4. Okay? Now, which one's obviously easier? The bottom one, right? But to really understand this, that's why we're putting them in piecewise functions, so you can understand the pieces of it and what's going on there. Okay, I want you to do 6 through 10 now. 6 through 10, it's the same kind of problem, same kind of deal, except for they did a little shifting. They did a horizontal and a vertical shift. So that problem that we did at the first of class for bell work was to get you ready for this kind of a problem right here. See if you can do the same thing now. Record this again. So if you're going to watch this again at home, all I'm going to do is just show it to you right there so you can see it. Just switch the x and y coordinates, right? Okay, on this one right here, we've got to simplify these. So we got to simplify each one of these square roots. Right now we have 4 minus the square root of 50. Well, 50 breaks down to 25 and 2, and that breaks down to 5 and 5. So we have a pair of 5s, a low 2. You guys remember doing this? Okay, so it's going to be 5 root 2. So it's 4 minus 5 root 2. This is going to be 7 plus 3 root 18. Except for 18 breaks down into 6 times 3, right? And that breaks down to 2 times 3, so I have a pair of 3s. I have a loner 2, so it's going to be 3 root 2. But it already has a 3 in front of it, so 3 times 3 is 9 root 2. Okay, 72 breaks down into 2 and 36. That breaks down to 6 and 6. And you know what? If you guys got a pair like that, you don't have to go any further. Just take one of those, and it's 6 root 2. But it has a 2 in front of it, so 2 times 6 is 12. So it's going to be negative 12 root 2. And then, okay, and then what we do is we go through and we combine. We have a 4 plus 7 is what? 4 plus 7 is 11 minus 12. So negative 1. Then right here we have a negative 5 root 2. These are all root 2s. We can add them together. Negative 5 root 2 plus 9 root 2. All we do is add negative 5 and 9. What does that make? 4 root 2. And 4 root 2 minus a negative 12 root 2. What happens when you minus a negative? You add. So 4 plus 12 root 2. 4 root 2 plus 12 root 2 would make 16 root 2. And that would be your answer. Do you understand that? This one down here, 13 is already simplified, so it's just negative 10 minus negative 11 would be 21. No, negative 10 plus 11 would be what? 1. Negative root 13 minus 5 root 13 is going to be negative 6 root 13. And that's the answer for that one. By the way, these two problems are on your assignment. Okay? Now, your assignment, it's actually pretty easy. You got 3 reflections to do like that first one. You do have a couple of problems that you have to know about taking the absolute value of these functions, flipping them over the x-axis. And then you got some like these at the end, okay? Pick it up on your way out if you want to here. I'll put some down right here. Yeah, if you don't want to, you get a 0, but... Okay, grab an assignment on your way out. Thank you, guys. Grab an assignment on your way out. Did you get one, Kurt? Did you get one? Huh? Hey, is that thing off over there? Go hit the, is it recording or not? Grab one. They're all the same. Some of them are just upside down, aren't they?
That one doesn't have one side.
Oh, hey, we're missing a side on that one. Hey, here's the other one. Okay.